So for this integral, you split it up, or the way I would do it is you split it up into 4 sine of 2x dx minus the integral of 12 cosine of 3x. Essentially you are dividing by 2 and by 3, but there's a reason why we do that. So on the when I have two functions, when I have kind of like a function within a function or something like that, I use u substitution. Then I'm going to say u equals 2x, and I'll take the derivative of both sides. Actually, this is the differential of both sides, du. Usually we do du dx, right? Whoops, dx. What I'm going to do, when what you do for u substitution is, and I'll never do this again, but du dx would be just regular 2, right? And then I'm going to multiply both sides by dx. So I get du equals 2 dx. And then I'm going to solve for dx to get 1/2 du. So I'm going to replace dx with 1/2 du, and I'm going to replace u with 2x. I'm going to replace 2x with u. That's where we get the dividing by 2. That's why it'll be a 1/2 there. But sometimes it's not always that simple. So it's better to do the substitution because maybe you have an x squared or something on the inside of the function. And in which case the derivative, this part would change. So here, if I replace everything, I'll have the 4 on the outside. I'll have sine of u, and then the dx changed to 1/2 du. And I'll move this 1/2 out to the front, and that will be where I get the 2 from. Sine of u du, and that's just cosine of u, 2, plus c, and that's 2 cosine of 2x plus c. And then I'll do the same thing for this. U equals 3x, du equals 3 dx, and solve for dx. I get du over 3, or 1/3 du. So I have this minus integral of 12 cosine of u times du over 3. So this 3 I'll multiply and then I'll move everything out front, so that'll be minus 4 cosine of u du. I have everything in terms of u, that's what I want. You can't have u's and x's in there because then you won't be able to integrate. The integral of cosine is sine. Whoops, this is negative, isn't it? Because derivative of cosine is negative sine. Yeah, that's negative. Alright, so I have sine of u with minus 4 there and plus another constant. I don't know what this constant is, so if I just add those two together, it'll still be a constant that I don't know. So I'm just going to use one c value, and this would be negative 4 sine of 3x plus c, and that's how I get negative 2 cosine 2x minus 4 sine of 3x plus some constant c. And that's it. Hopefully that makes sense. You're using u substitution. Sometimes when it gets to be like an x squared there, then u would be x squared du would equal 2x dx, because you're just taking the differential, which is the same idea as the derivative. So then dx would be du over 2x, and hopefully this x would cancel out. Maybe there's an x there. It would cancel out with something inside your equation. So it's important to use the substitution and not just divide the thing from the inside, because sometimes you won't be able to divide anything because the inside will be something where the derivative is not just a constant. And there you go. That's u substitution.